In this video, we are going to work through an example of solving an equation with fractions. All right, so here's our equation. 5 plus 8 divided by a minus 2 equals 4a over a minus 2. All right, so this equation has fractions in it, and so the very first thing that we need to do is to check the LCD. All right, so here looking at 5, we can write 5 if we want as a fraction, but it would just be 5 over 1. Right, so there's no need to really include the 1 in the LCD. Then the only other thing we have in these fractions is the expression a minus 2. So that is going to be in the LCD. And again, you might be tempted to put 2 a minus 2's in here, but you really do not need 2 a minus 2's. All you need is the largest number that appears in any one denominator, right? So what you would do here and say is, are there any a minus, there's 0 a minus 2's in this fraction, right? In the bottom of this fraction. There's 1 a minus 2 here and 1 a minus 2 here. So that's 0, 1, and 1. The largest number of the numbers 0, 1, and 1 is 1. So therefore there would be 1 a minus 2 in the denominator, okay? All right, so once you find the denominator, then you would multiply through both sides of the equation by the LCD. All right, over here on the left side, this needs to be in parentheses, as does the a minus 2. I don't need to distribute over here on the right hand side, so there's no parentheses over here. All right, so next up is I'm going to distribute this a minus 2, right, to both of those terms inside the parentheses. On this one, I'm going to write it as 5 times a minus 2, just looks a little bit better. And on the second one, I have a minus 2. And then 8 over a minus 2. Now remember, right, the purpose of multiplying through the equation by the LCD is to get rid of the fractions. So if you've done this correctly, right, all of the fractions should disappear. Over here on this fraction on the right-hand side, or this right-hand side of this equation, I can go ahead and cancel. I have an a minus 2 up in the numerator of this fraction, right? Remember, you can always write that as over 1. If you get confused, it's lagging a little bit. Okay, so you can always write that as a minus 2 over 1. And so you have an a minus 2 in the denominator, a factor of a minus 2. In the bottom, you have a factor of a minus 2, so you can cancel those out, right? And so what I wind up with is 4a on the top, right? When I multiply these two fractions, 4a times 1, and then on the bottom I have 1, so I'm not going to bother to write the 1 there. Okay. All right. Next, I am going to do some simplification over here on the left-hand side. The first thing I'm going to do is to distribute this 5 through this parenthesis right here. So I'll wind up with 5a minus 10. And then here I can do some simplification. I've got a minus 2 on top, a minus 2 on the bottom, right? So again, you can think of that as being over 1. And you can simplify, right? I've got a factor of a minus 2 in the numerator, factor of a minus 2 in the denominator, so I can cancel those common factors out. And so what I wind up with is an 8 on the top and a 1 on the bottom, and that's just 8. And all of that is equal to 4a. Okay. All right, and so you can see now all of the fractions are gone. And so this is just a linear equation, and I would solve that like we were doing before. So first thing is to simplify both sides as much as possible. And over here on the left side, I've got some like terms, so I can combine those. Negative 10 plus 8 is negative 2. Okay, and then on the right-hand side, that's as simple as I can get it. So each side is now as simple as it can possibly be. What I want to do now is to use the addition principle, right, to get every term with an a on one side, every term without an a on the other side. So there's lots of ways to do that, but here all of the terms without an a are already on the left side. So that means I want to put all of the terms with an a over on the right side. And so an easy way to do that is to just subtract 5a from both sides. All right, so I would subtract 5a from both sides. On the left side, that's going to give me a negative 2. And on the right side, 4a minus 5a gives me minus 1a. Okay. All right. And so now what I want to do is I've almost solved for a, right? The only thing is I have minus 1a here. So I need to divide both sides by negative 1. All right, negative 2 divided by negative 1 is 2. Negative 1a divided by negative 1 is positive 1a. So we get a equals 2. All right. So remember, because we multiply through our LCD, our equation, by an LCD that had a variable in it, we must check our answers. Okay. So this 2 is only a possible solution. Okay, so for the check, what we need to do is we need to take that 2 and plug it into the LCD. So our LCD was a minus 2. If I take that 2 and plug it in for a into the LCD, I'm going to get 0 when I do that. Okay? And so that means that this 2 is not a solution. It has to be thrown out. So I'm going to go down here and throw that out. The problem was, let me come down here and cross that out. All right, so the problem was that there is no solution to this equation. All right, so the answer here is that there is no solution. We only had one possible solution, and we had to throw it out. Okay. So the issue, right, is this. To solve this equation, right, what we did was multiply through by both sides of the equation by a minus 2, right? At the time we did that, we did not know what the value was for this, right? We did not know what a minus 2 was. And the multiplication principle says that's only a valid step. It doesn't change the solution set if you multiply both sides by it has to be non-zero. You can't multiply both sides by 0 because that will change the solution set, all right? And at the time we didn't know that. And when we got down here, right, we got a equals 2 is the answer. We went back and checked, and what that means is that we multiplied both sides by 0, which is not valid. If I try to plug this 2 in, right, to check to see if it's a solution or not, on the bottom of this fraction, I'm going to get 8 over 2 minus 2 when I do that. Or in other words, I'll get 8 over 0. And that's an undefined expression, right? So therefore, 2 is not a solution to this equation. So even though we did everything perfectly, right, we still have to go back and check these solutions. All right. All right. So make sure that you check your solutions when you multiply through by an LCD. If you plug your possible solution back into the LCD and you get 0, you've got to throw that solution out. And if you throw away all of your solutions, then the answer is just no solution.